Okay, so here's a new practice problem. This is the one that I sent out in the update also, so make sure that you find this one and print it, or you can just write it on paper, okay? So, scenario A, a bicycle is moving at a speed of 10 meters per second. How much time does it take him to travel 60 meters? All right, so start with the chart, because that's always the best place to start. Oh, these are so hard to use. Okay, let's see, 0, no, hold on. God, I hate this thing. 1, pencil. Okay, there we go. Let's see. Okay, here we go. Let's try this. All right, so 0, 1, 2. We're going to start counting the seconds here. This is in seconds, and this is in meters. Okay? Assume we start at a position of 0 meters. Even though it doesn't say it, it probably should. And he's moving 10 meters per second, which means every second that passes by, he's going 10 meters further. So if he starts at 0 meters, he's going to go to 10. Then he's going to go to 20. And he's going to keep counting up by tens in his position change until he reaches a position of 60 meters. Okay? Right? So then if I follow this along, every second is going to be 3 seconds, 4 seconds, 5 seconds, 6 seconds. That's what it's going to take. Okay? In scenario B, which I would do first before you do any of the graphing, so you can get all the scaling right, it says, at what speed would he have to travel to cover the same distance in 2 seconds? Okay, so now all I'm getting is 2 seconds, but I still have to start at 0, and then I have to get all the way to 60. Okay, down in the calculations box, right, which I can't put on the screen without messing this up, I would make this calculation so you can figure it out. Okay, so the velocity is change in position over change in time. Right, and you're probably writing this down below, whoops, in the calculations box. Okay, t final minus t initial. Ugh, it's hard to, stop. That doesn't work. Okay, and then I'm going to go from 60 meters. The initial was 0 meters. Okay, divided by the initial time, or sorry, the final time was 2 seconds and the initial time was 0 seconds, which means I know this guy is going 30 meters per second. All right, because look, I only have one jump to make here from 0 to 60, so it's going to have to be 30. Okay, so down here, I can say I know his velocity now is 30 meters per second. Okay, meters per second, and you're going to always label these. Okay, and then I can go back to this guy, and he was going all the way. It's going to run out of space down here for 6, I think, right? But you'll be able to see it. And I know his velocity was 10 meters per second. Okay, lovely. Meters per second. Okay, so once I get all this stuff worked out, now it's time to start graphing it. All right, so my position, I know I need to go on my position graph all the way through to 6 seconds. Okay, and I need to get all the way to 60 meters, so I'm going to go by tens. Right, and for now, we're going to try to keep all the numbers pretty simple and clean, because I don't want you to get hung up on that, because it's not really the point of this. Okay, all right, so this guy's 0, 0, 1, 10, blah, 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 all the way up. Okay, and there's his line. All right, and then his velocity, 1, 2, 3, 4, 5, 6, right? And let's go 10, 20, 30 here. Okay, and you can pick whatever scale you want, it doesn't matter, and he's going to do this for 6 seconds, okay, at a constant speed of 10 meters per second, all right? The B guy, he starts at 0, 0, but at 1, he's already at 30, and at 2, he's already at 60. So he goes like this. Oof, here should be straighter. Okay, and he's going to go at here 30 meters per second, but just for 2 seconds. Okay, so don't put arrows on the ends of these because we don't know what happens after that. Okay, so let's look at the motion map. Remember, I want to scale my motion map the same as I scaled my position graph. All right, and it has to be the same for both guys, or else I can't really tell what's happening. All right, so this guy is at 0, then 30, then 60. So his arrows are super long because he is very fast. Okay, and that's my time equals 0. This one dot should be time equals 1. Notice I'm labeling it right by the dot. Okay, I'm labeling the times. All right, and this other guy, okay, you can scale this too, but I'm not going to because it's really hard to write with this stupid tablet. Okay, and he is going every 10 meters. He's getting a dot. Okay, because he's going to end up getting to the same place, but it takes him a lot longer. So this is his t equals 0 dot, 1, 2, 3, 4, 5, and then this one is his t equals 6 dot. Okay, all right, so, no, stop. Okay, all right, so this is what I mean when I say annotate the graphs, okay? So I'm going to use a different color, which I'm going to use blue, and I'm going to compare some things. Okay, this is what you need to be able to do on the quiz. Graph all this and then compare it, okay? So the B time for this guy is 2 seconds, okay? And the time for A is 6 seconds, right? I'm reading that off the time axis, which is down here, all right? And I see that here too. I see he's 6, he's time is 2, all right? Here I can also see that they have reached the same position, and they both started in the same place, so each of their displacements is the same, okay? Because they're ending here, they're both 60 meters, and I can see here, 0 to 60. Ah, God bless it, stop. I hate this thing. Here, 0 to 60, and here, 0 to 60, okay? So they both have undergone the same displacement here, okay? I see that A is slower because of his slope here, and B is faster. Okay, so I can see that B is faster than A, right? Because his slope is steeper. I also see that here. B is faster than A, because B is at 30 meters per second and A is only at 10 meters per second. Okay, and I can see that here also. All right, I can see their times again here, right? And I can see their times here, 6 to 2, okay? I also can see here again that they've reached the same position, right? When it stops, they're both at 60 meters, which I see here, and I see that here also, okay? On the velocity graph, remember I can see the area is the displacement. So this one's 30 times 2, which is 60 meters. All right, and I can also see it for this guy. But this one's 10 times 6, which is also 60 meters. Okay, both of these still show 60 meters. All right, let's see, what else would I be able to tell from this graph? They start in the same place, right? And they end in the same place. Yeah, that's it. Okay, all right, so I'm going to do the proportional reasoning next. Let me try to stop this first, and hopefully this doesn't wreck it, so hold on. Okay, all right, so I think I switched this, so now we can see the proportional reasoning, okay? So down here, I got to do this again. This guy, okay, all right, so let's see. Okay, so down here, we've already done this one, right? This is the one that we should have done up top. Okay, this is where we got 30 meters per second. Okay, and then you can also do A, okay, which his was 60 meters minus 0 meters in 6 seconds. Okay, that's how he became 10 meters per second. Okay, all right, so proportional reasoning, let's look and see what it says. The paper, okay. At what speed would he have to travel to cover the same distance in 2 seconds? Okay, so what I'm looking for is what is the same. Okay, so it says he traveled the same distance in 2 seconds, so he gets a 1. That means the same, right? Because he didn't change anything. I multiply by 1 and it stays the same. Okay, he wants to now cover the distance in 2 seconds. Okay. The old time was 6 seconds, all right? So 6 became 2, right, by multiplying by a third, right? Remember, when you multiply by the fraction, the number gets smaller. So the time has actually cut in a third. Ooh, this is a tricky one. Okay, so the time has cut in a third, right? So now I need to know, what do I put here? So if I have 1 over 1/3, that's the same as 1 times 3 over 1, right? When I do fractions, if it's on the bottom, I always call it on the bottom, then it's on the top. Okay, so that's going to be 3. So this is going to be a 3, right? And I know that because look, this was 10 and this was 30. It tripled, right? If I want to cover the same distance, that would be the sentence. I can't write it. You have to write it. The sentence. If I want to cover the same distance in a third of the time, I have to go 3 times as fast. Okay, so that should be the sentence. If I want to cover the same distance in a third of the time, I have to go 3 times as fast. Okay, so 3 times as fast is what they're asking us. So I'm going to put 3v here because the variable that they're asking for is the speed. Okay, the coefficient is 3. That means it's tripling. My original speed value was 10 meters per second. So my new speed or velocity, remember we're using them interchangeably, is 30 meters per second. So see this? This should be this. Okay? That was kind of a tricky one because of the fractions, right? So you got to remember this part, which is always a challenge, but that's okay. You can do it. I have faith in you. All right. Good. Okay. So there's another one on the back of the paper that if I were you, I would try to maybe work out. And if I get a chance tonight, I'll maybe try to make another video of that one and post it. Okay. But for now, use this one. Go back and annotate everything. Do the proportional reasoning for everything. Okay. And then try practice 6, number 1. All right. The end.